Hi, today we are going to look at our next section. This is 7.5. It's called Apply the Tangent Ratio. So we are going to get into a part of right triangles called trigonometry. And in fact, I want to kind of bring out my calculator here. Have you ever wondered about these three buttons, SIN, COS, and TAN? So these are considered trigonometry functions, and we are going to start to look at these items. So they have a place in right triangles and in similarity. Okay, so at the beginning here, a trigonometric ratio, basically a trigonometry ratio, is the ratio of the lengths of two sides of a right triangle. You will use trigonometric ratios to find the measure of a side or an acute angle in a right triangle. Okay, so kind of the key item here is this is working with right triangles, which is the unit we're working with currently, and so it helps us find a side length. The next item says the ratio of the lengths of the legs in a right triangle is constant for a given angle measure. Okay, so that means if we were to take a triangle, let's say we were to take a right triangle. So here is a leg and here is a leg. So this is saying that if I were to put these two numbers in a ratio, actually one more thing. Let's say this is a 30, 60, 90 triangle. Okay, so in every 30, 60, 90 triangle, small and large, the ratio of the two legs is always going to be the same because they're similar to each other. Okay, so consider, let's see. Let's say this is my 30-degree angle and then I make a smaller one. So what it's saying here, so I'm going to put here, this is a leg and a leg, 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 make a right angle. So first of all, I know these are similar by the AA similarity postulate. If they're similar, then the ratio of the legs is the same. So we can go one step further. If the ratio between the legs of two different triangles is the same, it's also going to have the same ratio of these two legs. All right, so let me just do one more thing here and then we'll move on. So let's take a 30, 60, 90. So let me draw the shorter leg, the longer leg, hypotenuse, 30. And then I'll draw a smaller one, shorter leg, longer leg, hypotenuse, 30. Let's just say that they are, one is twice the size of the other. So I'm going to call the short leg here 5 and the longer leg 10. Now, going off of our shortcuts, to go from, if this is the short leg and this is the short leg, to go from short to long, we had to multiply by square root of 3. So the ratio, or the side of the longer leg is 5 square root of 3. Got the same thing here. So because those two triangles are similar, I know this is true. I know the ratio between these sides, 10 over 5, is equal to the ratio of the longer sides, 10 square root of 3 over 5 square root of 3. I mean, and you can see it right here. These guys will cancel back out, so they both equal 2. This is going one step further to say all, for example, 30, 60, 90 triangles, the ratio of the legs within the one triangle is the same. Okay, so let's take one of these. Let's say we take 10 in a ratio with 10 square root of 3. 10 over 10 square root of 3. This is saying that it is equivalent to this ratio of the 5 over 5 square root of 3. Okay, well let's divide it out and see. So if I take 10 and I divide it by 10 square root of 3, I'm going to have to use parentheses here. 10 square root of 3, I'll just close the one after the 3, the one after the 10. I get this decimal, 0.577. Okay, if I do the same thing with the 5s, 5 divided by 5 square root of 3. See how I get the exact same decimal? That means the ratios are the same. So that particular ratio of the two legs is called the tangent ratio. Let me grab a highlighter here. Okay, so it's going to be the ratio of the two legs. Now, our calculator is programmed with that number. Okay, and there are tables, before calculators, they had tables worked out. So here, remember what I did with the 5 and the 5 square root of 3. So that was off the 30-degree angle. So let me kind of show you. If I use the tan button, that stands for tangent, and I type in, I'm going to have a degree measure here, and we'll get to all this in just a minute. But if I take the tangent of 30, there's that exact same decimal. And it's because all 30, 60, 90 triangles have that same ratio because they're all similar. So we're going to talk about a tangent, and then we're going to also talk about this. This is the sine and cosine button, and we'll get to that in the next lesson. Okay, so let's get into this key concept here. Let triangle ABC be a right triangle with acute angle A. Now we're going to generalize this for all acute angles, not just a 30. So here's your triangle. Here's angle A right here. Now here's how we're going to have to label some things up. Hypotenuse is, of course, the hypotenuse. So I will usually shorten that to the letter H. Now, of course, these are the two legs because that's your vocabulary. From angle A, though, this leg I'm pointing to is the opposite leg. Okay, so I often just call that O for opposite. This leg right next to angle A is adjacent to angle A, so we would call that the adjacent leg, or A. So I'm always going to have this scenario. From an angle, I'm always going to have an opposite leg and an adjacent leg. Of course, the hypotenuse is always opposite the 90, so it's never going to be an adjacent side. It's always just the hypotenuse. Now, the tangent here, the tangent of an angle is defined as the following. So it's going to be a fraction or a ratio, and it is going to contain the opposite leg, the length of the opposite leg over the length of the adjacent leg. And so that is what we will classify as the tangent. Okay, so that's what I did back here. If we look at it, from 30, 10 is my opposite leg, 10 square root of 3 is my adjacent leg. So 10 divided by 10 square root of 3 is this 5.77, but because it's always going to be that same number for every 30, 60, 90 triangle, we have it programmed into our calculator, and that's how the calculator knows the amount. Okay, so I want to stop there and just kind of let you practice that a little bit before we use that to find side lengths. I have a couple things here that I want to skip for now. Cotangent is an extension of tangent. It's abbreviated COT. It's really the reciprocal. This particular symbol here is called a theta. It's a Greek letter. It's a very generalized letter to represent an angle, like you would see it on the ACT, things like that. So if we don't have, instead of saying angle A, a lot of times you'll have that theta symbol, but that'll occasionally show up. You'll probably get to that more in Algebra 2 or pre-calculus. So for now, I'm not concerned with spending much time on cotangent. All right, I want to focus just on tangent. So we're going to kind of ignore this center area. All right, example 1. Find the tangent ratios. We are only going to write ratios. Find the tangent of x and the tangent of y. Let's skip cotangent for now. Let's just work on tangent. We are going to write each answer as a fraction. All right, so I want to come back up here. I am going to simply write this. The tangent of an angle is equal to the opposite leg from that angle over the adjacent leg of that angle. So I'm going to use a pencil here so I can erase it. All right, angle x, right here. From angle x. Now, first of all, here's the hypotenuse. From angle x, the 13 is the opposite leg, and the 84 is the adjacent leg. So I'm going to be able to say that the tangent of x is equal to the opposite leg is 13, the adjacent leg is 84. All right, and so that's all we're writing on this first one. Now, sometimes we convert this to decimals. If I wanted to, convert it to a decimal, I would just, 13 divided by 84. And so a lot of times we'd round to the nearest, actually 4 decimal places, but we won't always need decimals as we do that. Okay, I'm going to switch over to, we're going to do the tangent of y. Now, the reason I did a pencil here is because now if I'm sitting at y, my opposite and adjacent change perspective. So my opposite, I'm going to erase the O and the A. The opposite of y is now 84, and the adjacent of angle y is 13. Now remember, hypotenuse is always hypotenuse. That doesn't change. So the tangent of y is equal to the opposite is 84, the adjacent is 13. And so see how they're really reciprocals of each other. Okay, let's take a look at number 2. So what we have with tangent is let me back up. Because the tangent of a particular angle is always the same, that ratio is the same, we can use it to find missing side lengths. So this next example is really a good application of when we would need tangent. Find the value of x. So notice I have one angle measure. Of course, I could calculate this one, but I only have one side length. There's no way to use Pythagorean theorem here. I must have 2 side lengths for Pythagorean theorem. So we're going to use this idea of tangent or these trigonometric ratios when we can't do Pythagorean theorem. So here's what I want you to think kind of over to the side. The tangent of an angle is equal to the opposite leg over the adjacent leg. So I kind of want you to say that to yourself all the time. Tangent is equal to opposite over adjacent. I'm going to write this out. And so actually, let me add one more thing. I'm going to say that the tangent of, I'm going to put my theta in there. So this is a degree. So the tangent of a degree is equal to the opposite leg over the adjacent leg. So what I see here is from 28, x is my opposite leg, 15 is my adjacent leg. So here's how I'm going to set that up. The tangent of the degree measure, 28 degrees, is equal to, write a ratio, opposite over adjacent. Opposite is x, adjacent is 15. So here's the other thing I want you to recognize. I could figure this decimal out. Now, I haven't talked about a calculator yet. Your calculator needs to be in degrees. That's what this stands for. If your calculator looks like this, let me see if I can change it here. Okay. See how it says rad? It's not because my calculator is rad. That means radians. So we can't be in radians. That's a whole different subject. So most of these scientific calculators default to degrees. If you're using a graphing calculator, they almost all default to radians. So if you need help switching that setting, let me know. But you'll get the wrong answer if you're not in degrees. So I could type this in. I could do tangent of 28, and I get this number. Now, I could plug in, instead of tangent of 28, I could copy down this decimal. But I don't want to do that because I'm going to round it at some point. So I don't want to round to the very end. So when I look at this problem, I'm going to say this is simply a number equals x over 15. One way to solve this is to create a proportion. Once I have a proportion, I can cross multiply. All right, so I can go ahead and cross multiply by that, like this. So 1 times x is x, and then this one is going to be 15 times the tangent of 28. A number times a number. So here's what I'm going to do. I'm just going to let the calculator do the work. So I'm going to do 15 times, hit the tangent button of 28. And when I hit enter, it has done the work for me. Now, we are almost always going to round to the nearest tenth. The directions don't say, but let's go ahead and round to the nearest tenth. Okay, actually, yeah, let's do that. So this would round to, this 7 would bump it to a 0 or a 10 up to 8. So I'm going to call this approximately 8.0. And I did that just to emphasize I did some rounding. All right, so the length of that leg is about 8 units. All right, so we're just going to work on more solving, and then the next lesson we will get to the other two trigonometric functions. All right, I'm going to pause here and have a second video so this one doesn't get too long, and we will finish the rest of the examples.